Hello viewers, welcome to the session on kernel principal component analysis, which is also known as KPCA in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. Principal component analysis and linear discriminant analysis can only be applied to the datasets which are linearly separable. That is, it does an excellent job for the dataset which are linearly separable. But if we use it to a non-linear dataset, we might get a result which may not be the optimal dimensionality reduction. And kernel PCA does the job right here. It uses a kernel function to project the dataset into a higher dimensional feature space where it is linearly separable. So it is much similar to the idea of support vector machines. And when it comes to the application of kernel PCA, it is much similar to the applications of PCA and LDA. So you can just go through it once. Now let's understand it more clearly. When our dataset is linearly separable, then it is much clear with the PCA and LDA. But what if our dataset is non-linear? Then in such cases, the kernel PCA converts the lower dimensional data into a higher dimensional data and search for a plane that separates both the classes, and then it brings down to the two-dimensional data set. Then we can get into the non-linear data set in two-dimensional. Then we can get this circular separation, and it is much similar to the concept of support vector machines. Now let's straight away jump into your favorite hands-on session on kernel principal component analysis in Python. I am importing all the important libraries which may be required in our hands-on session. After that, I am reading my data set. See, it has been executed successfully, and the data set is containing the age and income and a deciding factor whether a customer is going to purchase a particular item or not. And after that, I am going to segregate my data set into independent and dependent variables data set. See, it has been executed successfully. And now I am going to split my data set into training and testing set. See, it has been executed successfully. For testing set, I have given the size as 25%, which automatically means that our model is going to be trained with 75% of the data. And after that, I am applying feature scaling, as in the age and income there is a huge gap of the value. To bring it down, I am going to use the feature scaling option. So you can see here, executing. See, it has executed successfully. After that, this is the main chunk of code for the kernel PCA. So in kernel PCA, from sklearn library, we are going to take from sklearn library, we are going to use decomposition module, and we are going to import kernel PCA class. And we have created here the object of kernel PCA, whose number of component, minimum requirement component we have given as 2, and kernel we have mentioned as R here, which stand for radial basis function. After that, I have fit and transform for training independent sets. So let me execute this chunk of code. So it has been executed successfully. Now let's predict after a dimensionality reduction through kernel model. So I'm going to use logistic regression for prediction, and I'm going to predict value after dimensionality reduction through kernel. So let me execute this chunk of code. See, it has been executed successfully. Now let's execute the confusion matrix. See, here you can see 6 plus 4 are the false values. So 90% should be the accuracy. Let's cross check it through this code. See, it has been executed successfully with 90% accuracy. And after that, let's visualize what we have predicted. Now here you can clearly see, after dimensionality reduction, the prediction is quite good, and the green ones in the red and the red ones in the green depicts the error in our prediction, and rest all are the good predictions. As usual, I have included code snippet for your quick revision, so you can pause your video right here and can take the screenshot of the same for your future reference. I hope this video proved fruitful to you. and hope you have gained something extra than what you were knowing earlier. Thank you.